Hello, my name is Adam. In this video, we are going to learn how to create the classic arcade game Centipede in Unity. Centipede is a 1981 fixed shooter arcade game developed and published by Atari. The primary objective is to shoot all the segments of a centipede that winds down the playing field. We will learn about shooting mechanics, player movement, object generation, and a lot more. If you need help at any point in the tutorial, feel free to join our Discord community where we can offer direct help. There's a link in the description of the video. Please consider subscribing to the channel to support the amount of effort it takes to create a video like this one. It would mean a lot to me, and it really helps drive the growth of my channel. Thank you. Enjoy the video. Let's begin by creating a new project using the Unity Hub. In the top right corner, we can click the New Project button. From here, we can choose the template we want to start with. In our case, we're going to choose the 2D template since this is going to be a 2D game. We can also choose which version of Unity we want to use. So I'm going to use Unity 2020.3. This is the current long-term support version. For this tutorial, though, it doesn't really matter. We won't really be utilizing anything that's specific to one version or another. So feel free to use whichever version. Name your project whatever you like. I'm going to just call it Centipede, and choose wherever you would like to save your project and go ahead and create the project. From here, it might take a couple minutes to initialize, so we'll pick it back up as soon as it finishes. Before we do anything, let's go ahead and import some sprites that we're going to use throughout the project. I'm going to actually create a new folder here by right-clicking in the project panel, create folder. I'm going to just create a folder here for sprites so we can keep everything organized. If you want to use the exact same sprites I'll be using, you can download them from the GitHub project. There will be a link in the description of the video. It'll take you to the repository here. You can click this download link, and then you can extract this folder here to find the entire project, and within the project there will be a assets and then sprites folder. I'm just going to use these same sprites. Since this is already an existing project, it includes these meta files. For now, you can ignore those. The meta files are generated by Unity automatically once they've been imported into a project. So I'm just going to take all of these PNG files. I'm going to drag them into our project panel down here. Let's go ahead and move these into the sprites folder. Then there's just a few settings we want to change on these sprites here. So if you click on one, you can change the import settings. You can actually click on all of them at once, so I can change all of them, since they're all going to have the same settings. But first, I'm going to change the pixels per unit to 8. All of these images are sort of 8 by 8 images. And so this means when the image or sprite is being displayed in our scene, 1 unit in our scene will be equal to 8 pixels. So it'll just kind of help keep everything normalized. Let's see what else. We also want to change the filter mode here to point. For pixel graphics, you usually want to use point. Otherwise, it can apply some filtering that's going to sort of change the style of the graphics a little bit. So it's not going to have that pixelated look to it. So we usually want point. And in our case, that's really all that matters. But since these are all small images, I can set the max size to maybe 32. The compression maybe to none, since these are all really tiny images anyways. Just really maximize the image quality. And that should be good for now. All right, let's just do a little bit of simple scene setup before we begin writing our scripts for our game. So in the left here is our hierarchy where we can see all the game objects that exist in our scene. And then on the right is our inspector. So when I select a game object, I can inspect all of the components and properties of that game object. Before we do anything, I'm actually going to go to our scene file here. I'm going to rename this to just Centipede. You can, of course, have multiple scenes. For some games, you might have a scene for your main menu, for level 1, level 2, etc. You can have all kinds of scenes. For this game, I'm just going to kind of keep everything in one scene. But potentially, if you build this game out more and more, you might want to have multiple scenes, in which case you can switch between them. So here in our hierarchy, let's choose our camera. You can see the preview of our camera in the corner here. We can also switch to our game view where we can see the full thing. I'm also previewing the game at a 1:1 aspect ratio. You can always customize that. You can change the aspect ratio you want to preview your game at. You can add new ones if you want to. So for our camera, first I want to change the background color to black. It's a pretty simple change. Feel free to obviously customize this to your preference. The other thing I want to do is change the size here. So what this is going to do is essentially change how much area the camera can see. So for example, if I increase this or decrease it, This white outline is representing what the camera can see. So if I increase this, I'm essentially giving myself more space to work with. The camera is able to see more within our scene. And so for this game, we're basically going to be following kind of a grid system. All of our objects will be displayed on a grid. And so I'm going to use it like a size of around 20. It should give us plenty of space to work with. We'll be able to have plenty of rows and columns to be able to put all of our objects. The only slight caveat here is I actually want to increase this by half a unit. Whatever size you end up doing, I would then add 0.5 to it. The reason for this is because, here, let me demonstrate it. Let me just drag a sprite into our scene so I can show you. So everything in our scene is going to be on a grid, right? So let's say this object is right against the border, right against the edge of our camera there. So -20, right? So everything's going to be perfectly aligned to whole numbers, 20, 19, 18, etc. You can see here it perfectly lines up with the edge of our camera, which is what we want. Let's say the size were just 20. Well, now when our object's at this whole number, it's actually halfway clipping outside of the bounds of the camera, which we don't want. And so we'd have to decrease this to, like, let's say 19, but now there's some extra space here. And so to make sure the object's perfectly kind of aligns to the edge of the screen or the edge of our camera, we can increase that by half a unit. All right, so that's good for now. I'm not going to really do much else in our scene, but as we continue to build out the game, we'll add more. Let's go ahead and add our blaster sprite to our scene so we can then write our first script for player movement. If I just take this sprite here and drag it into our hierarchy, it'll create a new game object with the sprite renderer component and assign that sprite to it. There's a couple other components I want to add as well. I want to add a rigid body 2D. Of course, the 2D version, since this is a 2D game, a rigid body turns this into a physics object. That means the physics of this object will be simulated via the physics engine. There's a few properties I want to change on here. So I can get rid of drag. I can just set this to 0. The angular drag has to do with rotation, but our object's not going to rotate it at all. In fact, I can even freeze the rotation just to make sure it doesn't rotate accidentally. You can freeze that there. And I also want to turn off gravity, because in our game we can kind of freely move up, down, left, right. There's not really a sense of gravity for this particular game, so we can set that to 0 as well. Next, I want to add a box collider 2D component. For the collider, any kind of collider, there's different shapes: box collider, circle collider, so on. These will define the collision area of our object, which is represented by this green outline. So I actually don't need to do anything else on this. All those settings are completely fine as their defaults. And so that's it in terms of our actual object. Let's go ahead and create a new folder now to contain all of our scripts, just to keep everything organized. So we can create a folder there called scripts. Then we can right click, create C# script, and I can create one called blaster. Once that script has been created, you can actually add it to your object. So if we reselect our object, we can drag this into the empty area at the bottom. You can also add it via this add component menu, and then we can start writing our script. Let's open up our blaster script. I'm going to be using VS Code throughout this tutorial. Feel free to use any editor you want. It doesn't really matter. It's just preference. If you are curious on how to set up VS Code for Unity, I do have another YouTube video for that. You can check that out. By default, Unity creates us a class that inherits from mono behavior. And then there's a couple functions here that are very commonly used. I actually like to kind of sort of delete everything and just start fresh. I also like to remove these two imports that aren't being used. That's just my preference. You don't necessarily have to do that, but like having a clean slate to work from. So to move our blaster object here, we need to get a reference to that rigid body component so we can add forces to it to handle movement. Let's go ahead and create a new variable, private rigid body 2D. I'm just going to call this rigid body. And there's actually a really old, sort of deprecated, obsolete property with this exact same name as part of one of these base classes. And so we get a little warning here. Because that property is kind of obsolete and deprecated, we can sort of ignore that. Or if we want to suppress that warning, we can just add the new keyword here. And to assign this value, I'm going to add our awake function. This function is called automatically by Unity. The first, I guess, essentially when your object is first created or initialized within your scene. Make sure you use capital letters here for the first letter of the functions. For any of the built-in Unity functions, it has to be exactly this, case sensitive, otherwise it won't get called. So in here we can say rigid body equals get component and get a reference to our component. So this is another function Unity provides that it's going to look on the same object that our script is on. So our script is running on this object. And when we say get component, it's going to look on the same object for that component that we specify. So in our case, rigid body 2D. If it can't find that component, it'll just get set to null, which will probably cause errors. All right. Next, let's go ahead and add our update function. So this function is called also automatically by Unity every single frame that this script is enabled, or this behavior is enabled. And this is usually where you're going to handle like user input or player input. And so we're going to assign, we actually need to create a new variable to store our direction, the direction the blaster is moving. This will be a vector2. Just call it direction. And in here we can assign our direction based on the user input. We can say direction.x equals input.get axis. And then we can say horizontal. And then direction.y equals input get axis vertical. Let me explain what these get axis is doing. So this is actually using Unity's older input system. There is a newer input system, but by default, the old input system it's still the default when you create a project. So if you go to your project settings, edit project settings, there's an input manager here with these different axes. So there's all these different buttons that are just by default included. So we can see there's horizontal and vertical. These are mapped to W, A, S, and D, as well as the arrow keys. And I think it even has like controller stuff built in. Or actually, I think there's more. Yeah, there's another set of horizontal and vertical, which are mapped to your like joysticks. So like, if you have a controller. So we can just kind of reuse these default settings that already are set up, which is really convenient. If you're using, you can use the new input system too, and that's fine as well. The only thing I really want to change on these is the gravity and sensitivity. So this is going to change like how quickly the value goes up and down when you press it. And we want the game, like we want the player to sort of move instantly. If I press left, I want it to instantly move left. I don't want it to be this slow, gradual process. And so with these default settings, it doesn't feel very good in my opinion. I'm just going to bump these up to like 1,000, just so it instantly starts and stops the input rather than like slowly accelerating and decelerating. Obviously, feel free to adjust these to your preference just based on how you want the game to feel. But I'm going to do this both for horizontal and vertical. We should be good there. All right, let's go back to our script here. That's update. That's setting our direction vector based on player inputs. We also need to now actually apply a force to our rigid body based on this direction. So this we'll do in another function called fixed update. So the difference between these is update runs every single frame your game is running, but the frame rate of your game might vary. Okay. Fixed update runs at a fixed time interval. It doesn't necessarily matter what the frame rate is. This is usually important when you're doing physics because you want the physics to be consistent. If the physics changes based on the frame rate of your game, you're going to get really inconsistent results. So we usually do physics related things inside fixed update. So here we can sort of calculate a new position for our object. And this is one thing. So although we are using rigid bodies, normally speaking, you would add a force. So normally you would say rigid body, add force, and that's going to move the object in different ways. And it's going to handle collision and stuff like that. For this game, we're not actually going to use normal forces. We're going to use something else. So let me show you how this works. But we need to sort of calculate the new position ourselves. So I'm going to get whatever the current position is. So we can say rigid body dot position. So this is whatever the current position of our object is. And now we can change that. So I can say position plus equals direction. And I actually want to normalize our direction. What that's going to do is going to make sure our vector always has a unit length of 1. The reason this is important is because let's say you're moving at a diagonal. The x, let's say, is 1 and the y is 1, which makes you move at a diagonal. But the unit length, the vector length, is actually bigger than 1. So you would move faster on a diagonal than if you were just to move up or down or left or right. So we don't want the inconsistency, so we can normalize our vector to make sure it always has a magnitude of 1. It's usually pretty common when you're doing like, you know, motion vectors or kind of direction vectors and stuff. We can times this by some scalar, like a speed variable, which we don't have yet. So let's go ahead and create that. This one we actually want to make public. That way we can customize the speed of our object in the editor. Maybe just by default, I'll set it to around like 20. But we can change that. That variable will show up on our script and we can just set it to anything we want. We can multiply this direction by our speed. And then finally, we also want to multiply this by time.fixed delta time. This will make sure that the amount that we are moving is sort of spread out over time. And we want to use fixed delta time here since we're in fixed update. If you're using the time in normal update, you would just use delta time. But in our case, fixed delta time. So that's our new position of our blaster. And then we can say rigid body dot move position. So we're going to move to this position. And this will still handle collision and things like that. That's good there. That's it for now. Let's go ahead and actually test this out. Go to our blaster object here. And you can see in our inspector, you can see that speed variable. So we can always customize that if we want to. Let's go ahead and run this. Yeah, now I can move up and down, left and right. Perfect. Feels great. Inputs are very responsive. They happen instantly because of those changes we made in our input manager. And that looks great. There is one problem here where I can move out of bounds. So that's going to be the next problem we tackle. So to prevent our blaster from moving out of bounds, we just simply need to add some barriers some invisible barriers so it can't pass beyond that. We can do that by right-clicking our hierarchy. We can create an empty object here. Let's reset the transform here, just so it defaults everything back to the normal values of 0. And let's add a box collider 2D here. And let's go ahead and switch to our scene view so we can see this object. So if I move this object, we can see the green outline of our collider. We essentially want to move this all the way to the edge of our border and then change the size on our box collider just to make sure it fits the entire screen here. So I'm maybe do, let's see, like 40. And we can do 50. And just make sure it covers the entire area. And we also want to make sure this is perfectly lined up with the edge. So let's do 21, a nice whole value there. Let's do the exact same thing on the other side. And actually, let me name this. I'm going to call this barrier. I can just duplicate this by right-clicking and choosing duplicate or pressing Control D or Command D if you're on a Mac. And we can move this to the opposite side. Whole value of 21, same size. So we have our 2 barriers there. That looks good. Go ahead and also create one at the very top and the very bottom. So let's duplicate this again. Let's move it back to the middle. Let's actually flip the size here. We need to change the size in the x-axis now. So let's do 50 and 1. Let's move this up. So we do 21 there. Let's duplicate this one more time. Do negative 21. We have 4 barriers kind of surrounding our scene there, which looks great. And let me just name all these barrier. And let's go ahead and test this out. So, yep, now I hit the edge and I can't move beyond it. So that looks perfect. And once again, I perfectly kind of line up with the edge of the screen based on the camera settings we used before of using the 0.5 there. Now, the only thing I don't really like is when I'm sort of scraping up against the edge, my movement kind of slows down a little bit. It doesn't feel super good. So something we can do to help that a little bit is to add a physics material to our blaster, which is going to sort of change how friction is applied when we collide with something. I'm actually going to create a new folder for this. Let's create a folder called, let's just call this physics. And I'm going to right click in here, create 2D physics material 2D. And I'm going to call this no friction. And you can see there's two properties, friction and bounciness. If I set the friction to 0, that'll allow us to kind of move up against that edge without it being so, without the friction kind of slowing us down. So we apply this material to our rigid body on our blaster. It should help a little bit just smooth that out. Yeah, that feels a lot better. Now I don't like slow down when I'm sort of it does still slow down a little bit because my the vectors, like I'm moving on a diagonal right now, so the vector changes, but it's not nearly as bad as it was. So it feels a lot smoother. And this will work too. Once there's mushrooms and other objects in our scene, you're not going to kind of get stuck up against them as much. You'll be able to sort of smoothly kind of collide with them and continue moving on. And it just helps a little bit. We also need to add a barrier towards the bottom middle-ish area because the player here, the blaster, shouldn't be able to freely move everywhere. They should sort of be restricted to an area towards the bottom. Let's go ahead and actually duplicate one of these barriers one more time. Let's take one of these horizontal ones and let's move this up to around, let's say, -10. That'll give the player basically all of this area down here to move around in. They shouldn't be able to freely go anywhere. They'll sort of sit within this. I think they refer to this as like the home area. You can change the name here, barrier. And let's move our blaster into that area. So let's move our blaster down in there. Let's spawn them at around, I don't know, -18. It should work pretty well. And there it goes. So we spawn towards the bottom. If we replay, I can, yeah, I hit that barrier there and I can't move anywhere beyond it. So this is good. But this is plenty of area for me to navigate around in. And once the centipede is within this area, the centipede will stay within this area. So it'll hit the bottom and then it'll go back up. Once it hits this barrier, it'll start to go back down. It stays within this area, which adds like an extra challenge to the game. Okay, let's focus on our dart next, the dart that you can shoot out of the blaster. Let's go ahead and just create that game object. Go to our sprites and let's drag this into our scene just like we did for the blaster. Now for the dart, we actually want to parent this game object to our blaster. That way when the blaster moves around, the dart will as well. Or at least before you, when you haven't shot the dart, it will sort of be sticking out of your, I guess, mouth. And then once you shoot it, it'll detach itself and be able to, move freely. But we can drag this object onto blaster here. And so it'll kind of create this nesting here. This indicates the dart is a child of this object. If I move our blaster, it moves both of them together. Now, of course, we want to reposition this. So we want to move this, let's say, well, yeah, so now if I set a value of 0, that's going to indicate it's the same position as the parent. So the parent's at -18, but 0 is the same. I want to just bring this up like 0.5. That way it kind of looks like it's sticking out of its mouth. You also might have saw that it sort of is on top of the blaster. It should probably be underneath. We can go to our settings, additional settings here for our sprite render, and we can change the order in the layer. I want to probably just set this to maybe -1. That way it sits behind it, and that works a little bit better. Really, I should probably do that for our blaster as a whole as well, where the blaster itself should always be the kind of on top of everything. That way, at some point, if there's like a mushroom or something, in case it clips over it a little bit or whatever, just to make sure our blaster is kind of always the most foreground element. So just increase that to 1, so it's always on top of everything. That all looks good. Now, we still need to add a couple more components to our dart before we can begin writing our script. So very similar to our blaster, we need a rigid body 2D component. And we can kind of do some of the same settings as we did before. We can turn off angular drag because there's not going to be any rotation. We don't need gravity. We can set that to 0. We can freeze the rotation. I think we can even... Oh, no, I was going to say, I was thinking we could freeze the x-axis because it only moves up and down. But when the blaster is moving, it's technically moving left and right as well. So that should be good. And let's also add a box glider 2D to our object here. And let's go to our scene view so we can visualize that. Yeah, so here the size of the collider, it doesn't quite line up with the actual visual of the dart. So I might want to adjust this a little bit so it lines up a little bit better. So let's say like 0.125, and I think 0.75 is the correct size. And then we just need to realign it there. I think this technically, mathematically, this should be -0.0625. So that's like perfectly lines up the collider with the actual kind of pixels of the dart. So that's good there. That'll just make the collision feel a little bit more accurate. All right, and that's it for now in terms of the setup of our dart. Then we can actually create our script as well. So let's go ahead and do that. Right click in our scripts folder, create C# script. We'll call this dart. And we will attach the script to our game object just like we did for the blaster. So let's go ahead and drag this into the empty space. And now we've got our script down there. All right, let's open up our script and start editing this. I'm going to delete these just like I usually do. Start with a clean slate here. For our dart, we once again need a reference to our rigid body components. So we can actually, apply some forces to it. Let's create a new variable for rigid body 2D. It's exact same as our blaster. I'm going to get that same warning, so we can suppress that with the new keyword there. We also need a reference to our collider as well. So same thing here, collider 2D. I could be more specific if I needed to. I could say box collider 2D, but just generic collider 2D works for us. This property also is one of those obsolete, sort of deprecated ones from an old version of Unity, so I can suppress that as well with new keyword. And the reason we need a reference to our collider is because we need to actually turn on and off the collider when when the dart has not been shot yet. We need to disable the collider. That way it doesn't like collide with the player or other things. And only once you shoot it will it actually turn on the collider. And then we also need a reference to the parent. Well, let me explain that a little bit more. But let's create a variable that's of type transform. And let's call this parent. Let's go ahead and assign these different values in our awake function. Once again, this function is called automatically by Unity when the object is first initialized, or the script is. We can rigid body equals get component, rigid body 2D. We can also set our collider here, get component, collider 2D. And our parent here, we actually can reference or access the parent via transform.parent. And so I want to assign that parent equals transform.parent. The reason we need this is because when we shoot the dart, we're going to detach the dart from the parent. And then later on, we need to reattach it. And so we need to sort of save which object this is parented to. That way later we can detach it. Because once we detach it, well then this will just be null. We won't know who it was previously attached to. And so this will allow us to kind of save that so we can reattach it later. Now, initially when the dart sort of spawns, it's sitting in the player's or the blaster's mouth. So we want to turn off the collider. You say collider.enabled equals false. And we also want to turn off the physics simulation on our rigid body. We don't want to simulate any physics or anything. So to do that, we can say rigid body.bodyType equals rigid body type 2D.kinematic. This is going to essentially turn off the physics simulation. We probably should even do that in this scene just in case. So initially this will be set to kinematic here, and then our collider will be disabled. That way it just doesn't cause any problems initially. All right, so let's go back to our Dart script. Go ahead and add our update function so we can handle input to determine when the dart actually gets fired. So somewhat similar to what we did in our blaster, but a little bit different. We'll say if input.getButton, and we can say fire1. This is another input that is included by default in the input manager. So we go back to our project settings, input manager, there's actually fire 1, 2, 3. So by default, this control is mapped to left control or mouse 0. So I can click my mouse button to to fire. Maybe I want to change this to like space. I think that would be more appropriate. And yeah, we're good there. Everything else looks fine. Yeah, there's even one for, once again, the joystick. So we're good there. Feel free to obviously change these. You can add new ones if you want to. You know, just kind of then change the string here. So when we fire, we need to deparent the dart from the blaster. So we can say transform set parent to null. So this will detach it so it can kind of move freely. We need to re-enable the rigid body simulation. So we can say rigid body type equals rigid body type 2D.dynamic. And then we want to re-enable our collider. That way collision can actually happen between the dart and other objects. The only thing that's missing here is we only want to be able to fire the dart if it isn't currently fired. So only for my implementation of the game, and I think this is true for the original, there's only one active dart at a time. You cannot, like, it's not spawning new darts every single time you click or fire. So it's one dart. If it's already active, then you can't fire it again. And so to prevent, the way we can do that is we can say if rigid body is kinematic, that sort of implies, you know, when the dart is not active, it's kinematic, right? So while it's essentially not active, then we will check for input. And if you press the input, we will fire it. This way, once it has been fired, it's no longer, this will be false. And so you wouldn't be able to like refire it a second time until later on it gets reset. So that's checking for input, actually firing it. The movement itself will be handled in fixed update, just like we did for our blaster. So here we can calculate our new position. Let's get the current position from our rigid body. We can then update this position. And I can just say it's always going to move up. Right, so vector2.up times some speed variable once again. So let's add a speed variable. Public float speed. What should this be default to? Let's default this to around 50 maybe. You can obviously customize that. And by making it public, it'll show up in the editor so you can freely change that value. And then just like our blaster, we need to multiply this by time.fixed delta time. That way this movement happens. It gets spread out over time. And then we can move our position on our rigid body. Rigid body move position, we'll pass in that new position. The only thing missing now is we should only be moving the dart if it's been fired. And so kind of we need the opposite of this. If it's not kinematic, that means it's been fired. And so that's when we want to do this code. So we can say if it's not rigid body is kinematic. So the exclamation mark means not. We'll move this code inside there. All right. So if it's not kinematic, which essentially implies it has been fired, we will move it. Otherwise, if it's kinematic, which means it's kind of not been fired, we won't run this code. And finally, we need to reset or reattach the dart to the blaster whenever it collides with something. So the way we can handle collision or check for collision is via a function called onCollisionEnter2D. And then this has a parameter called collision2D. We'll just call this collision. Once again, make sure for these functions, they're typed exactly like this, case sensitive. Otherwise, they won't get called because these are called automatically by Unity. So whenever we collide with anything, we need to essentially do the opposite of this. We need to reattach it. So we need to reset the parent to its initial parent, which we saved when the object was initialized. We need to reset the position to be, you know, wherever the blaster is. And this is where we can say local position instead of just normal position. The position here is world space, whereas local position is local space. It's going to be relative to the parent. And so this is where for us, it's really just 0, 0, 0. Or well, really the Y, we want to offset it a little bit. So if you remember correct, if we remember on our Dart, we said 0, 0.50. This is local space since it's attached or parented to the blaster. It's relative to the blaster. We can say 0.5 there. So that'll kind of reposition it in the mouth of the blaster. And let's set our rigid body to be kinematic again. That way it's not moving. And let's turn off our collider. That way it doesn't collide with things even though it's not active. And that looks good. Let's go ahead and test all of this out. So let's run our game. So I can shoot here. So the problem, you can actually see in the hierarchy, it is detaching. So it's working, it's getting detached and firing, but it's not moving. And that's because as soon as it detaches, it instantly collides with our player. And so then it gets reattached. But we need to turn off collision between these two objects. One of the ways we can do that is via physics layers. So if we click on our, let's start with our blaster. On this object, there's this layer property up here. We can add different layers or assign them to different layers. And then in our project settings, we can say which layers can collide with others. So let's go ahead and add a new layer. Let's add one for player and let's add one for Dart. So I'm just going to add just whatever available user layers there are. Player and Dart. Let's go to our blaster. Let's assign this to player. No, we don't want to change the children. And then let's assign our Dart to Dart. Now in our project settings, edit project settings, you can go to physics 2D. And at the bottom here will be this collision matrix, which allow you to turn on and off collision between different layers. So we want to disable collision between the player and the Dart. So if we uncheck that, now those two won't collide with one another. So let's rerun this and try it again. There we go. So now I can click and so it's hitting this invisible barrier here. And so it's getting reset. So that's no good. We want our Dart to be able to go through that invisible barrier. So we might need to do something very similar where we sort of set that on its own layer. That way we can ignore the collision between it. So let's go ahead and find that barrier there. I guess it'll probably be on all of our barriers. Let's find that one at least. Okay, so let's go here. Let's go to our layer again, add layer, add one called barrier. Let's go ahead and assign this there. And actually we should really assign that to all of them. We can select all and set them all to be barrier. And let's go ahead and try that out. So if we go to our project settings, now we can disable collision between the Dart and the barrier. Let's see, so barrier and Dart. Yeah, there we go. So we can turn that off. And now we can rerun again. It should be able to travel through there. It does. The only issue now is that because it doesn't collide with the barrier at the top, it keeps going on forever and there's nothing to like essentially reset it. So just for this very top barrier, we actually don't want to set the layer. We can just set it back to the default. That way it'll make sure that when the bullet or the Dart hits this top barrier, it'll always collide with it, and which will make it reset. There we go. So now as soon as it hits the top, it gets reset. I can shoot again, but it traverses through this invisible one in the middle. I guess the sides and bottom don't really matter since you can't actually hit those, but this looks good. Next, we can start to handle our mushrooms. Before we can really spawn all of our mushrooms, we need to create a prefab for it though. Let's go ahead and go to our sprites folder. Let's find just the first mushroom here and let's drag that into our scene. Let's call this just mushroom. And let's add a few components to this. Let's add we don't need a rigid body because the mushrooms don't move, but we do need a box collider, 2D. That way collision can be detected between the mushroom and other objects like our Dart or Centipede. Don't really need to change any of those. It works perfectly. Our outline there fills the object perfectly. So from here, to create a prefab, we just need to drag this object into our project panel. It's going to turn this object essentially into an asset that we can then reuse over and over again. Let me actually create a folder for our prefabs. Just once again, keep everything organized. Let's open this up. If we just drag this into our prefabs folder here, it turns it into an asset that we can now reuse. So I can actually delete it from our scene, because now I have this as an asset. So I can always like respawn these as I want to, right? I can always just have a bunch of them now. And so now really what we're going to do is we're going to write a script to spawn them dynamically in our scene. So let's go ahead and create a new script called, well, we're going to need two scripts. So we're going to need a script for the mushroom itself. So let's go ahead and just create that. And we're also going to need a script for our mushroom field. So the mushroom script will handle like the health and like the states and health for each individual mushroom. It'll have its own script on it. The mushroom field will handle like spawning all the mushrooms as a whole. So let's actually go to our prefab for our mushroom, and let's make sure we add the mushroom script to it. That way every instance of our prefab here has that same script. For our field, one thing we want to do is indicate the area that the mushrooms can spawn within. And I can do this via a box collider, actually. Let's create an empty object in our scene. Let's reset the transform so it's kind of normalized to 0. I'm just going to call this maybe field, or I could call it mushroom field. And let's add a box collider 2D here. And we can just adjust the size here to kind of indicate this is the area I want the mushrooms to spawn within. So let's say 40, for example. That'll be good. It can spawn all the way up against this edge. And once again, if I'm spawning this right at 40, it's gonna well, I guess it's 20, because it's 20 in each direction would be 40. But if I'm right at 20, it's gonna perfectly align against the edge. So for the size here, I want it to be half a unit away from the edge there. And then the Y can vary a little bit. You know, maybe 30, 32. We do like 33, I think, actually works well, because once again, if these are on a grid, let's say this is like -16, or let's say -17. Yeah, so like that works perfectly, because you can see our blaster and the mushroom are perfectly on two separate rows. So at 33 here, so actually we could maybe even go a little bit more. I think though, if this is an even number, yeah, this is the problem where, oh no, that actually should be fine. Because then this can spawn, if it spawns right on the edge there, yeah, that should be good. So 34, let's try that. We can always adjust it if we need to. So 40, 34, feel free to adjust. It doesn't really matter, I guess. And let's go ahead, and the important thing here is we mark this as a trigger. We don't actually want anything to collide with this. This is just sort of, we're just going to use to indicate the bounds of the area we can spawn mushrooms in. We don't want anything to collide with it. So marking this as a trigger, it allows objects to go through each other. And you can still check to see if some object has collided with this, but it won't actually like cause the object to stop its movement. So trigger there, that's really important. In this object here, we can bring our mushroom field onto. All right, let's go ahead and open up our mushroom field script. Let's start with this one. Just gonna delete these like I usually do. Start with a clean slate here. So for our field, we need a reference to that collider component that we added, so we can check what the bounds of it is. So let's go ahead and add a variable for box collider 2D. I'm gonna call this one, let's call it maybe area. We also want a variable for our prefab. That way we can reinstantiate that prefab over and over again. This one I want to make public, so I can assign a reference to the prefab in the editor. And it's going to be of type mushroom. This means whatever object I assign as the prefab has to have the script, the mushroom script on it. If I try to assign any other game object as the prefab, it won't work unless it has that mushroom script on it. And then maybe we add a variable to indicate how many mushrooms you want to spawn. So this can just be an integer, maybe I say amount, and maybe this defaults to 50, so we can spawn 50 mushrooms initially. And you know, maybe as you continue playing the game, it spawns more and more and more. Let's go ahead and add our awake function so we can get our reference to our area here. We have via get component, box glider 2D. And let's create a function called maybe generate. So we can say private void generate here. And we can get, so we should call this function in start. So start's another built-in Unity function. This function is going to get called automatically the very first frame that this script runs. And so in here we can say generate. In our generate function, we can get the bounds of our collider. We say bounds equals area.bounds. So area is that box collider. Then we can loop over however many mushrooms we want to spawn. So we can create a kind of standard for loop here for int I equals 0. I is less than amount, I plus. And then we just need to sort of pick a random position within these bounds and then instantiate our prefab. So let's say position here, I guess just initially it'll be 0, and then we'll assign the X and Y independently. So we can say random.range, and we can give a min and a max. And so the min and max is just going to come from our bounds. So we can say bounds.min.x, bounds.max.x, and same thing for our Y here. Random.range, bounds.min.y, bounds.max.y. Now, the only important thing here is we need to round these values to the nearest whole value. That way everything stays kind of aligned perfectly to a grid. We can say mathf.round, kind of wrap that whole thing in a round function. Mathf.round. And there we go. So we're taking this whole thing and putting it inside round. And now we can instantiate a new object, a new clone of our mushroom here. So there's a function called instantiate. We pass in the object we want to clone or copy. This is our prefab. We can then pass in the position we want to spawn it. So that's that position we just calculated. And then quaternion is their rotation. We don't need rotation. We can just say identity. And then we can parent it if we want to. So we can actually parent it to our field, our mushroom field. We don't need to do that, but it might help to just keep things organized. So this will just be transform. And transform is referring to the mushroom field's transform. The only other thing we might want to do now, might as well do this now, is if you regenerate, actually, no, we'll do it later when we get to our game manager. I was going to say we should add a function to clear the field of mushrooms, but we can worry about that a little bit later. Let's go ahead and test this out. Let's go to our field. We do need to assign our prefab here. So let's go to our prefabs. Let's drag that into our field there. And let's go ahead and play. See what happens. There we go. Got a bunch of mushrooms everywhere. Looks good. Let's check their positions all line up. Want to try to get some. Yeah, it's all perfect. This one's right on the edge. It looks perfect. And I think we're all good to go. The important thing too is none of the mushrooms will spawn on top of the blaster, right? So the edge of our field is right on top or right below before our blaster. So they're not going to accidentally spawn on top of the blaster. Now obviously I can move around. I can collide with these. So everything looks good there. Perfect. This looks great. All right, next, let's handle the mushroom states themselves. So this will be sort of like the mushroom's health, where when you shoot them, they have a few different states that'll cycle between, and then the mushroom will disappear. So let's go ahead and go to our mushroom script that we had created. I'm going to start with a clean slate like I usually do. And for here, we need to add a variable to indicate the different sprites that we'll use for each of the states of the mushroom. So there's 4 of them, or you can obviously have more than 4, but for our case, I have 4. I guess we don't have to specify anything in the code here, but we need to create an array of sprites. So this is declaring an array of sprite. I'm just going to call this states, I'm making this public so I can actually assign those in the editor. We also need a reference to the sprite renderer on our mushroom so we can change this sprite anytime the state changes. Let's get sprite renderer here. And then we just need a variable for the mushroom's current health. We can say private int health here. Go ahead and add our awake function. Let's assign our sprite renderer via get component. And health is going to initially get set to however many sprites you have, right? So if there's 4 sprites, then the health is 4. We can say health equals states.length. Now from here, we need to determine when the dart collides with our mushroom. We need to reduce the health and then swap out the sprite, or change the sprite on our renderer here. So to check for collision, we did this before. On collision, enter 2D. This takes a collision 2D parameter here. I'll just call this collision. Now the difference between this one and our dart is we need to check what is colliding with the mushroom. The health is only going to change if a dart collides with it. So the way we can do that is saying if collisions, we're going to access some of the data in that collision object here. If collision.gameObject.layer equals layer mask name to layer dart, then we know we collided with our dart. So earlier we assigned the dart game object to its own layer. We can look at that here. If we select our dart, it is on its own layer, also called dart. And so this is a way we're just comparing the layer of the object we collided with to see if it is that same layer. And if it is, then we know we collided with a dart. Make sure this string here is exactly the same spelling and casing as the layer you assigned. Now what happens when we collide with the dart? Well, we need to damage the mushroom. Let's go ahead and create a new function for that. Let's say damage here. And maybe we can say damage by some amount. And so here we can say damage 1. We're going to apply 1 damage to our mushroom anytime the dart hits it. When in our damage function, we want to first reduce the health. So health minus equals the amount. And then we need to check, well, is there still health remaining on our mushroom, or is there not? So we can say if health is greater than 0, then we need to reassign the sprite. Else, we need to delete this mushroom. So deleting is easy. We just say destroy game object. This is going to destroy this game object from our scene. If the mushroom still has health remaining, we just simply need to change the sprite on our sprite renderer. So sprite renderer dot sprite equals states. You're going to access our array here. The index is going to be essentially health, but it needs to be the inverse of health. So it needs to actually be states.length minus health. So it's the inverse. Because if state, the first sprite in here is going to be when you're full health. The second sprite, so it sort of needs to be the inverse of our health. We just subtract by the length there and we're good to go. I think that should be good. Go ahead and make sure we update that. So let's go to our prefab mushroom, our mushroom prefab. We have our states array here. Let's go ahead and assign our sprites to this. So I have 4 sprites for my game. So I'm going to set the array to 4. I'm going to then drag each of these in. Mushroom 1, 2, 3, and 4. And let's go ahead and test this out. If I shoot one, notice how it goes to the next state. So every time I shoot it, it goes to the next state. And this looks great. Perfect. So this works awesome. And once it fully, once it has no more health, it just gets completely destroyed and removed from the scene. Awesome. Now let's focus on the most complicated aspect of this game, which is the centipede itself. We're going to kind of break it down into a few different steps, but let's start by just creating a prefab for one segment of the centipede. So let's go ahead and take our, let's say, centipede body, and let's drag this into the scene. I'm going to rename this to Centipede Segment. And there's a few, components we need to add on this, just like we've done for all of the others. So we've got our sprite render, that's good. We need a box collider 2D. We can handle collision. And this is a very minor thing, but it's somewhat important. We want to change the size here. We just want to reduce this ever so slightly. Like for example, just like 0.99. The reason for this is because you're going to have a bunch of these segments kind of lined up one after another, right? And the centipede can technically collide with itself. So if you, at some point, the centipede will break apart and there'll be multiple of them kind of moving around. And if they collide with one another, it'll cause them to move to the next row and inverse their direction and so on. And so we don't want these segments to trigger the collision. And so if they're both at one, they're technically, let's assume once again, these are all on a grid. These technically will be touching each other, right? They're technically touching each other, which might trigger that collision code. Let's just set these to 0.99 just to guarantee they're not truly touching one another. But it's also not, like we could make this even lower if we wanted to, but we don't want to make it too low. Otherwise the bullet itself will be able to fit in between the segments. So we don't want that. So maybe, 975 or something. It doesn't really matter, just so long as they're not actually touching one another. All right, so we have our segment here. Box collider. We do need a script as well. Let's go ahead and just create a script for Centipede Segment. And let's go ahead and attach that script to our game object here. And I think that's it for now. We can just drag this into our scene or not into our scene, from our scene into our prefabs folder to create a new prefab. And so we're good to go there. Now we can delete it from our scene. Now that we have this asset, we can always re-add those. All right, so next we want to actually, let's just focus on spawning the centipede and then we can do the movement after. Let's create a new script for the centipede as a whole. So kind of similar to the mushrooms, we have a script for each individual segment, and then we're gonna have another script to kind of manage it as a whole. And let's go ahead and open up this script. So here, let's start with a clean slate here, delete all that. And the first thing we want to do is add various properties or variables here. We want one for our prefab. So just like we did for the mushroom field, let's add our centipede segment. I'm just going to call this prefab, or maybe I'll call it segment prefab. Be a little bit more specific. What else? We need to have a list. We need to create a list so we can store all of the segments in the list. To create a list, we need to import using system.collections.generic. And then we can declare a list here. So private list. We have to specialize or specify what type of list it is. So it's going to be a list of centipede segments. I'll just call this segments. We can actually initialize it right here too. So new list. So same type, empty parentheses. What else do we need? We need probably a reference to our two sprites, our body sprite and our head sprite. That way we can reassign the sprite accordingly based on where in the centipede the segment is. Let's create some variables for our head sprite and our body sprite. What else for spawning purposes? Maybe that's it for now. I think all the other things will be for movement. So I think this is good for now. Let's go ahead and add a start function. And inside of our start function, we can call, let's say, a respawn function. So let's add another function called respawn. And And here we'll call that. Later on, we will call this in other places as well. But initially, when the script starts, we'll respawn our centipede. When we respawn the centipede, one thing we want to do is we want to clear out our list and destroy all the existing segments, so we're starting fresh. So for our list, we can say for each centipede segment in segments, so in our list. So for each segment in our list, we will destroy the object. So segment.gameObject. Make sure you say .gameObject, because if you just say segment, it's just destroying the script. It's not destroying the game object as a whole. So .gameObject. And then we can clear our list. Segments.clear. That way we're starting fresh. And now we can instantiate our new segments. So this is where it's similar to our mushroom field. We can loop. Oh, that's one property we are missing. We should specify like what is the size of our centipede. So we can add a public integer, maybe call the size. I'm gonna maybe default it to 12. Feel free to customize that to your preference. So here we can say for int I equals 0, I is less than the size I plus plus. And for each loop here, each iteration of our loop, we want to instantiate a new segment, add it to our list, and position it accordingly. So let's first just get it instantiated, because the positioning is a little bit more complicated. So segment here is going to equal the output of our instantiate function. In our mushroom field, we didn't need to actually, this function actually returns the object you're instantiating. We didn't need to do anything in our mushroom field because we're not really tracking them in a list or anything. But in here we are, so we need to actually assign the result of this to some variable. Instantiate our segment prefab. And then we can add that to our list. So we can say segments.add segment. And that's good for now. We just need to pass in the other parameters here for position and rotation. So let's calculate our position. It's going to be a vector 2. And there's a little bit of math we need to do here. So really, we should spawn this wherever the parent wherever the parent centipede is. Like, it's going to spawn in that position. So just wherever this object is, it's going to start here. But then we need to offset it to the left or right. Each segment will be offset to the left or right by essentially whatever the index is. For example, we can say vector2 dot left times I, and we should put this in parentheses here for order of operations. I guess we don't technically need it, but so what this is doing essentially is saying if I is 0, then 0 times, well, left is -1 in the x, so it's going to offset it by 0. When I is 1, that's going to offset it by -1. When I is 2, it's going to offset it by -2, 3, -3, etc. So it's going to offset each segment kind of one after another, initially wherever our position is here. Now this is yelling at me because I'm trying to add a vector 3 and a vector 2 together, which it doesn't like. There's actually one more thing I want to do this anyways. This position here, just to be safe, I want to make sure that this position is aligned to the grid. So I'm going to write just a little utility function that's going to round this position to the nearest whole values. That way it's always it's always properly aligned on our grid. Let's create a little util function. We're going to return a vector 2. I'm going to call our function here grid position. It's going to take in a position and it's going to return so we're going to take in a vector 2 and it's going to return a new vector 2. So all I'm going to do is I'm going to round this to the nearest whole value. Position.x, same thing for y. Math.round. All right, so I'm taking this position, I'm rounding it to the nearest whole value, and then I can just return it back again. And so now here, I can say grid position transformed up. So it's just a little utility function to just guarantee that this position is aligned to a grid. And then it also just happens to get rid of that error because I'm returning a vector 2. So I'm adding a vector 2 plus another vector 2, and there's no error there. So finally, we can pass this position into our instantiate function. Rotation, we don't care about, so we can just set that to identity, and we're good to go there. So let's test this out. I know that was kind of a lot. Once again, this centipede is going to be the most complicated part of our project here. We actually need to add our centipede to our scene here. So let's create an empty object. Let's reset the transform. I'm going to call this centipede. I'm going to add our main centipede script to this. And now I need to assign all these various properties. So let's assign our segment to there. Let's assign our sprites. So head sprite, body sprite, and size initially is 12. So that's all good. I want to spawn the centipede towards the top. So let's just say at a position of 20. Yeah, it actually sort of wants to be right on the edge there. So 20, and we should be good. Let's run it and see what happens. Perfect. So it spawns right at the top, and once again, each segment is offset 1 by 1 by 1 by 1. The only thing missing here is our very first segment in here needs to change its sprite. To be able to set the sprite on each segment, we need to start to build out our centipede segment script a little bit more. So let's go ahead and open this up. Start with a clean slate here. And I need to get a reference to the sprite renderer on this segment. That way I can update the sprite accordingly. So let's go ahead and add this. And actually, I'm going to make this is going to be a little bit different than any of the other variables we add. I'm going to make it public. But I'm going to say it get private set. So what this is doing is it's creating a property that has a public getter and a private setter. So that means I'll be able to access this variable from other scripts, but I won't be able to assign this variable from another script. And we can assign this in our awake function, just like we've been doing for everything else. Sprite render equals get component, sprite renderer. And so now I can actually assign, I can access this from our other script here. So when we create our segment, I can say segment.sprite-render.sprite equals, and I can either choose head or body. The head will always be the first one. So if I equals 0, we're going to use our head sprite. Otherwise, we'll use the body sprite. This syntax here is called a ternary statement. It's kind of like writing an if statement where you have a condition here that you're evaluating to true or false. If this evaluates to true, it uses this value. If this evaluates to false, it uses this value. This is called a ternary statement. I equals 0, we use head. Otherwise, we use body. Let's test that out. And we should already have our script on our prefab. Yeah, so we have our segment script on our prefab. Make sure that that's there. There we go. So now we've got the head and then all the body follow. That's good. We need to put a little bit more structure in place before we can start to handle the centipede's movement. Let's go to our centipede segment script. And one of the things we need to do is for each segment to track which segment is ahead of it and which segment is behind it. This is essentially like a doubly linked list. For any of you programmers out there who are familiar with that data structure, this is sort of like a doubly linked list. We're not actually going to use a linked list here, but we're going to kind of follow that same general pattern where we have different nodes in each or segments, and each segment kind of tracks what's ahead of it, what's behind it. That way we can always traverse through the entire centipede if we need to, as well as handle other things. So let's go ahead and create some new variables in here. And we actually want to make these, we're going to do something very similar to this. So we're going to make these public. We're going to call these centipede segment. Let's name this one ahead. And this will be a get set. So it's a fully public property, public getter, public setter. I don't want to just do this though, because then this will show up in the editor. Because we're not actually assigning this in the editor. I just want to be able to get it and set it from our other script here. So there's better encapsulation practices you could follow here, but there's no real benefit in our case. So get, set, same thing. So ahead and behind. So each segment is going to track which one's ahead of it, which one's behind it. And one way we can know if this segment is the head is if the one ahead of it is null. If there is nothing ahead of it, well, that must mean that this is the head segment. We might want to have a little property there to determine that. So we can have public bool is head. I'm going to write a little arrow here. So equal sign with a right kind of caret. And this will say ahead equals null, equals null. So now I can always check, if is head, I can execute some logic, because the way the segments there'll be different logic whether it's a head or not a head. So we kind of want this little utility property in here. And finally, I probably also want one more property to track the centipede itself. That way I can communicate back to the centipede as a whole to say, oh, hey, like this segment was destroyed. This segment was destroyed. And then the centipede, since it's tracking the full list of segments, it can update them and do things as needed. So a bunch of properties in here. We need to assign all of these programmatically. So for a centipede, that one's easy because we can just assign it whenever our segment is instantiated. So we can say segment dot centipede equals this. Because this is, I'm inside the centipede script right now, so this is referring to that same type. For the ahead and behind, after we've instantiated everything, we actually want to loop through everything one more time. That way we can assign all those values. So let's loop through everything one more time for int I equals 0. I is less than, let's say, segments.length. Segments.count I++. Here, let's get a reference to the segments at that index. So segments I. And now we can assign the ahead and behind. Let's create a little utility function for this. So let's say this function is going to return a segment. And we can say get segment at some index here. And this is going to, first, let's check that the index is not out of bounds. If the index is, or we should check if it is in bounds. So if it's greater than or equal to 0 and it is less than segments.count, we know that this index is within bounds, so we can access our list and return the segment at that index. If this index is out of bounds, well, then we need to return null, so it doesn't cause an error. If we try to access an index that's out of bounds, we'll get a exception. That's going to cause an error. Now, finally, here we can say segment.ahead equals get segment at index I-1, and segment.behind equals get segment at I+1. Perfect, right? So behind is, or ahead is actually the one that's in front of, like in the list, it's the one in front of you. And then behind is the one that's the next in our list. Oh, there we go. So now we're assigning all of these different properties here. And this will be needed as we start to build out the movement of our script a little bit more. All right, let's actually start to work on our centipede movement now, which is going to be the hardest part of this. So at any point, any segment could be a head segment or a body segment, because as you shoot a dart at the centipede, it's going to break into 2, and then you could break it into 3, and then you can break it into 4. So there could be there can be X amount of independently moving centipedes. And so that's where it gets a little bit tricky for movement purposes. I found the best way to do this is for each segment to sort of calculate a target position. And then we just simply need to always move towards that target position. And that target position will be calculated differently whether you're a head segment or a body segment. For body, it's pretty easy. Basically, the target position is just the position of the segment in front of you. For the head, it gets a little bit more complicated, but we'll break it down into sort of those two different steps. So let's add some variables here. Let's have one for our target position that I mentioned. This will be a vector 2. We also need a variable to track our direction, the direction that this segment is moving. And initially, let's say it's going to be moving to the right, and it's also going to be moving down. So we're not going to just say like position plus equals direction. This is more so like just keeping track of, I want to kind of independently, am I moving left or right? And then for the other axis, am I moving up or down? The way we actually move the segment itself will be a little bit different, but we still need to keep track of the general direction it's moving. So direction, target position. Now, as soon as the segment sort of spawns, I guess, we want to assign our target position just to be its current position. So we can say target position equals transform.position. All right, now let's add our update function. So our update function is going to get called automatically by Unity every single frame. And this is where we'll actually do the movement. And so let's actually just write the movement code itself, because that's pretty straightforward. The hard part is going to be how we actually calculate this value here. Let's assume that this value is assigned, and let's just update the position of our segment. So let's start with our current position. We transform.position. Then let's go ahead and we can say transform.position equals vector2 dot move towards, and then we can say current position. Right, so we need to pass in the current and move towards a target. So obviously our target position that we have, and then the max distance delta is essentially like sort of like a speed. It's essentially like your speed. Like it can only move this amount per frame. That's basically speed. We actually haven't created any speed variables yet, so we can go ahead and do that. And I'm actually going to create that speed variable in our main Centipede script, because I want the entire Centipede to move at the same speed. I guess you could, if you really wanted, you could have each segment move at different speeds, but then the Centipede wouldn't really stay together as a whole. I'm going to kind of create a new variable here for speed. This will be a float. Let's say maybe initially the speed is just 1. We can update that in the editor as we need to. Now for speed here, we want to say centipede.speed times time.delta time. We want this to happen over time. Just because this whole line of code is pretty long, I'm just going to put this into its own variable just to improve the readability a little bit here. Let's do this just to shorten this line of code a little bit. It's still fairly long, but so we're going to update our position to move towards the target position at some speed. Speed will be defined in our Centipede, and we are moving towards that position over time. So time to delta time. All right, next, we also want to set the rotation of our segments based on the direction we're moving. So there's just a little bit of math here. We can say, let's take a look at what's the direction from our current position to the target position. We can get a vector to indicate the direction there. This is like the overall direction that the segment is moving, but from, its current position to the very next target position, whatever that next grid position is, what's the vector there? And so to do that, let's just call this like movement direction. We just subtract target position minus current position. And then we do want to normalize this. So let's wrap that in parentheses and then say normalized. That way it always has a magnitude of 1. From here, from this vector, we can actually calculate an angle. So there's a pretty neat function. I believe this is trigonometry, if I'm not mistaken. mathf.atan2. We got to pass in a y and an x here. And so this is just our vector. So movement direction y, movement direction x. This is going to calculate the angle of this vector. And then we can essentially set our rotation of our segment based on that angle. Now rotations are defined as quaternions, which is a kind of a more complex math concept that I'm not going to get into, but there is a function on quaternion.angle axis. So this creates a quaternion given an angle and a given axis. Angle axis, the angle of course is that angle that we just calculated. And the axis is the, also this angle though, we need to convert to degrees. This atan returns it in radians. And this function takes degrees. Angle axis takes degrees. So we need to convert that. That's pretty simple. We just say mathf.rad 2 degrees. Radians 2 degrees. Our axis here is just basically the axis we want to rotate on. And we want to rotate on the z-axis. So the z-axis can simply be written as vector 3.forward. So 0x, 0y, 1 in the z. So that will rotate on our z-axis. So that's going to make sure that the segment is always rotated to the direction you're moving. This is a pretty minor thing overall. You might not even notice it if it wasn't here, but it is pretty nice. So that's the actual movement and rotation of our segment. But what's missing is we still haven't calculated what this actual target position is. So that's next. So to calculate our target position, we need different logic based on the head, if it's the head piece or the body piece. So let's go ahead and create 2 separate functions for each of those. Let's call one maybe update head segment. And let's call one update body segment. And for our head segment here, anytime we reach our target position, we're gonna re-update it, recalculate the new target position, right? And so the one way we can do this is to check the distance between our current position and our target position. And if that is, close enough, well, then we know we've basically reached our target position and we should then calculate the next one. And we're only going to do that for the head piece because the head piece will then inform the body pieces to update their positions as well. So at the very top of our update function, we want to do it before we actually apply movement because ultimately we want to calculate the target position first. And once again, we only want to do this if it's the head piece. So we're going to say if is head from this property we created earlier. And if the distance, vector2.distance between A and B, so A is going to be our current position, B is going to be our current target position. If let's say that's like less than 0.1, so if you're very close to reaching, we don't want to say 0 because it might not always be exactly 0. So just to be safe, we'll give a little bit of a buffer there. But if you're basically very close to the target position, we're going to then calculate the next target position. So this is where we'll call update head segment. Now within these functions, we're going to handle the logic to actually calculate that, target position. But before we do that, I want to finish getting the structure in place. After calculating that new target position, we want to update the next segment in our centipede. So I can say if behind does not equal null, then we can update that one. And we know the one behind it is always going to be a body piece if this is the head one. So I can say update body segment. Then same thing here. Once that segment gets updated, it needs to tell the next segments behind it to also update. So it's going to kind of traverse through the whole thing. The reason we check for null is because once you're at the tail, there won't be any more segment behind it. And so it'll stop at that point. So this looks good. That's the structure. Now we actually just need to calculate the target positions. Let's start with the body one because it's a lot simpler. Really, all we need to do is say target position equals the same. We want to move to wherever the piece ahead of it is. because each body piece sort of follows the one ahead of it. So we're just gonna say head.transform that position. The only thing we need to do is we do always want to make sure our target positions are aligned to the grid, right? So the transform position will not always be perfect whole values. These need to be. Our target position needs to be nice whole values. So we just need to round all of this to the grid, which we already have a function for that in our other Centipede script. And go ahead and maybe just copy this over, and then we can call this here. So we're just rounding it all to align to the grid, and we're good there. The only other thing we want to do is we want to make sure our direction is being updated as well to whatever the one ahead of it is. That way, eventually, if the segment, the centipede splits out into two different ones, the direction's not going to be completely invalid because it was never being updated. We're just going to say direction equals ahead that direction. We just directly copy that over. So that's it. That's all we need to do for our body one. That one's pretty straightforward. The head one will be a little bit more complicated. So initially for the head segment, we need to see where it's at on the grid currently. So let's have a vector2 called grid position. Let's call this grid, or we're going to call our utility function here, and we're going to pass in our current position. We're going to round our current position to the grid, and our target position is always going to be our current grid position, but then we're going to update it in the x-axis, whichever direction we're moving, right? So target position.x plus equals direction.x. Right, so we take our current grid position. If we're moving to the right, well then the target position is 1 to the right, and so on, or to the left, right? Obviously, there's going to be more we need to do here, but let's initially test this out. Oh, and also I noticed our speed here is only set to 1. We probably should have maybe set this to, let's say 20. I can also change the default here. I guess I don't need to change the default because that's the whole point of making it public. So you can just change it in the editor, but I'm going to default that to 20. Make sure it's set there. Let's test this out. Perfect. So everything's moving in uniform with one another. Obviously, it doesn't recognize the barriers or anything like that, but at least we have some movement in place. We can continue to build off of this. Now we need to handle the collision on our centipede. Let's go back to our centipede segment script. We need to add a little bit more logic to our update head segment here. So after we calculate this target position, we need to check if that's a valid position. We need to check if there is a mushroom at that position or if there's a barrier there. And if there is, we need to reverse the direction and then start to advance to the next row. We can do this by saying if physics2d.overlap box. So this is going to let us know if there is a collider at some point. We can say target position here. We want to check at the target position if there's a collider there, some mushroom or barrier or something. The size here doesn't actually matter. We can just say 0 because we just care about that point in space. We're not trying to really, actually need like a box per se. Angle can be 0. We don't need it to be rotated. We do need a layer mask here. This is how you can specify which layers are we checking for. So in other words, what are the layers that the centipede can collide with? Let's go ahead and add this layer mask to our centipede script. I can add a new variable here called layer mask. I'm going to call this collision mask. Once again, this is going to indicate which layers the centipede can collide with. We can pass that in here, centipede.collision mask. So if there is something where you can collide with at this target position, well, it's not a valid position. And so we need to change it. First, though, we need to reverse the direction. So we can say direction.x equals negative direction.x. So once it advances to the next row, it'll start to move in the opposite direction. We need to reassign our target position now. It's just going to be our current grid position .x, and then the y is going to be the row, the next row. So target position.y equals grid position.y plus direction.y. So whichever vertical direction we're moving in, we will advance to that new row. Then there will be some logic to check if we're within the home area or not, but for now this is good. Go ahead and try this out. We do need to assign our collision mass though, so let's go ahead and update this. The centipede should be able to collide with barriers, should be able to collide with mushrooms, and also with other centipedes as well, but we don't have those other layers, so let's go ahead and add those. Let's go to our mushroom prefab. Let's add a new layer here. I'm going to create a layer for mushroom as well as for centipede. Let's assign these. So mushroom, we're going to assign to mushroom. Centipede segment, we're going to assign to centipede. And let's go back to our collision mask and assign all of these. That looks good. Barrier, mushroom, and centipede. Those are the only things the centipede is looking for in order for it to change its movement direction. Let's go ahead and test this out now. So it hits the barrier and it moves to the next row. It's going to hit a mushroom, it moves to the next row. So all that looks perfect. So it'll just continue to traverse all the way down. And let's speed up its speed, or change its speed, so we can see if it gets all the way to the bottom. Perfect. Now, once it gets to the bottom, it continues going because we haven't written the code yet to handle its reversing the vertical direction. So to do this, we should start by creating a new invisible collider to represent the area of the home area. So very similar to kind of how we created some of these other barriers, or to our field, I should say. We kind of have this box collider that just represents the bounds of the mushroom field. We can do the same thing for our home area. So I'm going to create an empty game object in our scene. Let's call this home to reset the transform. I'm going to add a box collider 2D. We're going to mark it as a trigger because we don't actually want anything to physically collide with this. And now we can adjust the position here. So size 50. Or in the X, just to make sure it covers the whole area. Maybe the home, or vertically it's maybe Y, and then we can reposition this as needed. So make sure this is aligned properly to the grid area. So maybe -14. We don't actually necessarily need it to go all the way to the very bottom of the board. That way the player does still have somewhat of a safe area. I guess it's up to you. You can customize that how you want. Let's see how it lines up with our other barriers, because we had this barrier here. So these two, so these two should kind of line up a little bit better. So I think this is too big. Let's maybe reduce this to 8. Yeah, there we go. So that actually works. We want the home one to be like halfway inside there. Like it doesn't have to be, but that should work pretty well. Cool. Yeah, and then now there's the space at the bottom where the player can still be safe. So that should be good. But obviously feel free to adjust that to your preference. All right, so let's go back to our centipede script and let's add a variable so we can keep track of that. So this would be a box collider 2D. We're going to call this the home area. And let's rearrange those or organize those. And let's go ahead and assign that now. Centipede. Yeah, so let's drag in our home area there. Cool. Now we can go back to our centipede segment script and we can finish the remainder of our logic here. So after we set our new target position, we need to verify that that new target position is not outside of the bounds of our home. Well, depending on the direction we're moving. So first, let's get the bounds of our home. Home bounds equals centipede.home area.bounds. And so if we're moving down, and we're moving down if y is 1, then we need to check, have we moved past, is this target position below the maximum? So if the target position is below this area, then it needs to start going up. We need to reverse the Y direction, start moving up again. This bottom part is max, the top is min. So here we can say direction is 1, so that means we're moving down, and the target position dot Y is greater than homebounds dot max dot Y. That means we're going to reverse direction. So direction is going to be negative, or direction dot Y is negative direction dot Y. So same as this, really, but just for direction now. And our target position dot Y needs to get reassigned to grid position dot Y plus direction dot Y. So same thing as this, just in the Y axis. Or it is the exact same thing. We're just reassigning that now that the direction is changing. Now we also need to do the same thing if we are moving up and we are outside of the min, so which would be above it. So we can say, or we can wrap this entire thing in parentheses. That's like one thing. Then, or we can kind of do the same thing here. So another set of parentheses, direction.y equals -1. So it means we're moving up, and the target position.y is less than homebounds.min.y. So if we're gone past it, or we've gone, above it, then we will reverse the direction. So this will guarantee we stay within the home bounds upon reaching it. I think that's it. I think that's all that remains for our Centipede movement. So let's go ahead and test this out. We already assigned our home area, so we should be good. Let's just go ahead and test it. And I'm going to increase the speed so to save some time here. And I'll slow it down once it gets further. Okay, so great. We've hit the bottom. Yep, and now it's going up again. And we can see, so boom, it moves. Here, let me move my blaster out of the way. Yep, perfect. So as soon as we hit to that last one, then it can't go any further, so it goes back up. And in this case, it's actually really interesting because it sort of gets stuck here where, just the layout, the particular layout of these mushrooms makes it so it needs to actually just go back down again. So that all looks great. So movement is all good. Next, we need to handle splitting the centipede into multiple centipedes whenever it collides with a dart. Let's go ahead and go to our centipede segment script, and let's add a function to check for collision. So this will look just the same as the other ones we've done. On collision, enter 2D, takes in a collision 2D object. Make sure not to confuse this with collider 2D. It should be collision 2D. Here we can check if we specifically have collided with the dart by looking at the layer, just like we did for one of our other scripts. So if collision.gameObject.layer equals layer mask name to layer dart. Well, now we know we've collided with the dart, and we should remove this segment from our centipede. So we need to do a number of things in this script. So let's go ahead and add a new function here. I'm going to make this public because I need to be able to call it from an external class, from a different class. So I'm going to call this maybe remove. We'll pass in the segment where we want to remove. And we can call that here. So we can say centipede.remove this. So we're removing this segment from the centipede. In here, there's a few things we want to do. So first, we actually want to instantiate a mushroom at the same position of our segment. So basically the segment sort of gets replaced with a mushroom. So we need a reference to our mushroom prefab. So let's go ahead and add that mushroom prefab here. And we can instantiate this. So we can say mushroom prefab. We need a position here. Maybe we say mushroom position, or just position, I guess. This will be the same position of our segment, although we want to make sure it's aligned to the grid. So let's wrap this in grid position here so it rounds everything. Pass that in. Rotation we don't care about, so we can just say quaternary identity. That's good. We're instantiating a new mushroom at that same position of our segment. Then we need to remove our segment from the list. So segments.remove segment. And then we can destroy this segment itself. Destroy segment.gameObject. Make sure you say gameObject, not just the script. And there's actually a couple more things we want to do. So we want to relink these other segments. So let's say, for example, let's say these circles here are different segments. Maybe you're destroying this middle one here. So this one is going to get destroyed. Well, when this gets destroyed, you know, it's going to change. Like, let's say this is moving to the right as well. So this will get replaced with a mushroom. This one now becomes the new head. And then there's nothing ahead of it anymore because the one that was ahead is now destroyed. And then same thing for the one here. The one that was behind it, well, it's destroyed. It no longer exists. So we need to null these out for the respective ones. So we can say if the segment ahead of the one being destroyed is not null, well, then we can reassign the one behind. So the one ahead, the one behind of the one ahead is the one being destroyed. We null it out. And then same thing in the opposite direction. If the one behind is not null, then the one behind, the one that's ahead of the one behind is the one being destroyed. So we null it out. So sorry if that's confusing, but yeah, we just need to reassign those that way. Because remember, we have this little property here that says this is considered the head segment if there's nothing ahead of it. And so by nulling this out, it's now going to consider that one to be another head, right? Because now these become like two independent, these will become two independent centipedes. It splits it, and now they're two completely independent centipedes. And instead, there's a mushroom here now. Now, the other thing is, because there's a mushroom here, it should hit it and then, you know, reverse direction. So these two will kind of split apart and move at their own direction. We should just recall our update head segment. So it resets the target position. It'll indicate, oh, there's a mushroom there, you know, and then it'll reverse it and everything. So we just need to call that function. So segment.behind.update head segment. I get an error here because this is private, so I need to make this public now. And that should handle making sure that it goes in a new direction once it kind of splits apart. So a lot of times it will do that anyways, but just in case, we'll do that. I think that's all we need. I think that's it. So let's go ahead and test this out. Oh, you know what? Yeah, well, let's test it out first. We do need to make sure we assign our mushroom prefab now that we added that. So let's drag that in, and then let's run this. Shoot one of these. There it goes. It splits out. A mushroom spawned. It split, and the two splits kind of went in their own direction. Now we got three of them moving all at the same time. Now there's a couple problems I see. One is the new segments, the head sprites aren't being assigned. So that's a problem. And so let's go ahead and go to our Centipede script. And we need to reassign this one because this one's now a head. So we can say behind dot sprite render dot sprite equals head sprite. One becomes the new head. So we assign the sprite there. That looks good. And let's see. So that's one problem fixed. The other problem, it's a subtle one. It's not even necessarily a problem. But let's say you had two segments here. Obviously right next to each other, of course. I'm just illustrating this, so it's not going to be perfect. But let's say your dart hits these sort of right in the middle, where technically it's colliding with both. It would actually destroy both, which maybe is fine, but It happens kind of a lot, and I don't really like it. It feels like you're able to destroy the centipede way too quickly. It's essentially destroying multiple at the same time. So there's a little bit of a hack we can do to fix this. Let's go to our centipede segment script. Here, when we check for collision, we can sort of check to see... We can do some stuff in here to make sure that this logic of removing the segment will only happen for one if it does indeed collide with multiple. So what we can do is we can disable the collider on our dart immediately. So collision.collider is referring to the dart's collider in this case. We can disable this immediately as soon as it collides with one of the segments. And then we can add another condition to our if statement here to say we're only going to run this if the collider is enabled, right? So if collision.collider.enabled and it's the dart, then we will remove it. So essentially, if this were to be called multiple times within the same frame, for the first one, it's going to be enabled. And so it'll go through, it'll remove that segment, but then the dart gets disabled. And so then when this code gets executed for the second one it collided with, well, now it's considered disabled. And so it won't remove the second one. So it's just sort of forcing it to make sure it only removes one at a time, just in a scenario where it technically collides with multiple at the exact same time. A little bit of a hack. It's not even necessarily a problem, but personally, I feel like that improves the gameplay a little bit. So, and the thing is, the dart collider is going to get disabled anyways. So, because that just with the script or the code we wrote earlier for the dart, it gets disabled anyways when it collides with something. So this doesn't really cause any issues. All right, let's just do one final test, but I think we're already good here. Let's make sure the sprites are being updated. Yeah, so I already saw. So there, now we've got the head sprite is being reassigned. And yep, now in this case, it's just a head completely by itself. That's totally fine. So this all looks great. So we got multiple segments that all can kind of move independently of one another. And perfect. Everything's good there. All right, at this point, we basically have a working game in Centipede. We just sort of need to tie everything together with some scoring, some lives, some UI, things like that. Let's start by creating a game manager that can manage all of those things. Create a new C# script here called Game Manager. I'm going to create an empty object in our scene. Call this Game Manager. I'm going to drag this on there. Let's reset the transformer. That doesn't really matter. I'm going to move this to the top here. All right, let's edit the script. Let's clear everything. Start fresh here. So we're going to somewhat implement a singleton design pattern here, which will allow us to access our game manager from any other class. And with a singleton, it also implies there's only a single instance of our game manager that we can then access anywhere. So to do that, we need to declare a static variable. Our game manager here is going to manage it, like it's going to keep a reference to itself statically. And we'll call this instance. And this will be a getter with a private setter. So because this is static, we can access it from any class without needing a specific instance. We can just access this from the class itself. And so here, when our game manager is initialized, we need to assign this here. But we only want to assign it if it's null. So if an instance doesn't already exist, well, then this becomes the instance. Our sole kind of single instance. If an instance already does exist, well, we shouldn't be creating another one. So we can just destroy the game object that is being, the second instance that's being created. That won't actually happen, but once again, for a proper singleton, you would want to make sure you can't ever instantiate more than one. And then whenever an instance of the game manager is destroyed, or any game object is destroyed, Unity calls onDestroy for that object. And so here we can say if the instance is this, well, then we should clear it out. We should null it. So That way, the next time another one gets initialized, we can reassign it again. So this is a very simple version of a singleton. There's normally more you need to do. So for some games, this isn't enough, and there could potentially be problems you run into. But for our purposes here, this is plenty fine. So let's finish creating the rest of the structure of our game manager. So the other thing we want to do is just keep track of a number of references to some of our important game objects. Like our blaster, for example, we want a reference to that. We want a reference to our centipede. We need a reference to our mushroom field. We'll call this mushroom field. We also need like score and lives as well. At least for now, this should be good. And then let's create all the various functions we will need, but we'll implement them individually. So first, let's add our start function. So this is going to be called by Unity, the very first frame our game manager runs. When we start, we should assign all of those references so we can find them in our scene. We can't use get component here because these references aren't components of our game manager. They're just other objects in our scene. So we could say find object of type. Same thing for the others. Find object of type centipede, mushroom field, find object of type mushroom field. And then let's create the various functions that we'll need to manage the state of our game. So there'll be a new game function, and we'll come back to implementing this. There'll be a game over function. There will be a reset round function. So when you die, we should reset the round. And then there should be a next level function, I guess we can call it. Those are kind of some of the main functions that'll happen, or different events that'll happen when the game changes state. So the only thing I think we can do now is we can say new game here. So we can call new game when it first starts. But the rest of this, we'll start to implement these one by one. All right, let's start with our new game function here. So whenever a new game starts, there's a number of things we need to do. We should reset our score to 0. We should reset our lives to whatever you want the initial amount of lives to be. Let's say 3. We should respawn our other objects. Our blaster centipede, we should regenerate our mushroom field. For the centipede, we already have a respawn function. Just make sure it's public so you can access it from our game manager. So that is already in place, which is good. Our blaster, we don't have a respawn function, so let's add one to this. Add a public respawn function here. Really, we just need to reassign the transform position. But we need to know what the initial spawn position is. So let's create a variable for that called spawn position. We will assign this initially when the blaster is initialized to whatever its current position is. And then here we'll do the opposite of that, where we'll reset the transform position to the spawn position. The only other thing we probably want to do is make sure our object is active. So set active to true. I can't type. Set active to true. This will make sure our blaster is activated again, because when we lose, we'll probably deactivate it. So I think that's all we need for that. So let's respawn our blaster. And then we need to clear and regenerate our mushroom field as well. So for this, we should probably keep track of a list of our mushrooms so we can destroy them. So why don't we add a list of mushrooms here? Let's import system collections.generic. So we can declare a list here. It's going to be a list of mushroom. We'll just simply call this mushrooms. I can initialize this in our awake function to a new list, new empty list. When we generate a mushroom, we need to add it to that list. So here we need to actually get a reference to the object being instantiated and add it to our list. And then we should probably add a new function for clearing our mushroom field. In which case we will loop through each of the mushrooms in our list, and we will destroy all of these game objects. Make sure you say .gameObject, otherwise you would just be destroying the script itself, which is not enough. I'm going to destroy the full game object, and then we can clear our list of mushrooms, so it's empty again. So these two functions now we can call from our game manager. Make sure they're both public. We can call them from our game manager. So here we can say mushroom field clear, mushroom field generates. I think we're good there. Cool. Oh, and also now that we're doing all this from the game manager, we don't need our start function in here, because the game manager is going to handle doing all this. So we can actually get rid of start. Same thing in our blaster is good. The same thing in our centipede though. We don't need to call respawn from our centipede script anymore, because the game manager is going to then call all this whenever the game starts or whenever a new game happens. So let's just verify that that works. We run our game and yep, centipede respawns, everything respawns, so we're good there. All right, let's handle the next function, which will be game over. So this is sort of the opposite here. Really, all we need to do when you get a game over is disable the blaster so the player can't move around or anything. So we can just say blaster game object set active to false. And then we'll probably do some UI stuff later, but we'll treat the UI as its own section. So we'll come back to this. But we need the ability to reset the game when you do have a game over. And so maybe, for example, you get a game over, it displays some UI, which we'll get to, and then you can press any key to reset the game to play again. So we can check for input. So to do that, we need our update function. We can check for input here. We only want to check for this input if you're out of lives. So if you have a game over. If our lives is less than or equal to 0, and they, let's say, we can actually do any key down. So if I press literally any key, we can call new game again. That one's pretty straightforward. Game over, we disable the blaster. We will then check for input to see if we should start a new game, in which case the blaster and everything gets respawned. Remember, the blaster is going to set this to be active again. And that's really it. That's all we need for that. All right, let's do our reset round function next. So here, when you reset round, this will be handled when the player loses a life. So when the centipede collides with the player, then we will reset the round. So actually, let's go ahead and check for that collision first. So let's go to our centipede segment. We already have our on collision enter function. Here, let's just check for collision between the centipede and the player. So instead of, we can just use the same code here. Instead of checking for dart though, we will check for player instead. So if we collide with the player, then we will call that reset round function on our game manager. So this is where I can access the instance of our game manager from anywhere, and I can say reset round here. Now this function is private, so it's giving me an error. So I need to make sure this is public so I can access it from here. And then we're good to go. And just in case, so it doesn't execute any other logic beyond this, I will return. Okay, so in reset round, we want to decrement the number of lives. So that will get decreased by 1. If the lives is less than or equal to 0, that means you've gotten a game over. And then we can return, because we don't want to execute any other logic in this function. If you haven't run out of lives, well, we need to respawn the centipede. We need to respawn the blaster. And then we could regenerate the mushroom field, but we don't. It would actually, in the real game, I believe it just heals all the mushrooms instead of regenerating them. That way it feels like the same round, because if you regenerate them, it's going to feel like an entirely like new level almost. If we just heal them, they maintain their same positions and everything. And and it'll feel like you're just resetting that same exact round. We need the ability to heal our mushrooms. Why don't we go to our mushroom field? Actually, let's first go to our mushroom script itself. We should probably have a function on here to heal a mushroom. This will be a public function called heal. We're going to reset the health back to the max. So remember, if you have, let's say, 4 sprites that 4 different states for your mushroom, well, then the max health you can have is 4. So we just reset that. And then we just need to update the sprite again. And this one's easy because it'll always be the first sprite. So index 0 is always the first one in the array there. So that's good. Now we need to be able to loop through all of the mushrooms and call this function. So we can go to our mushroom field script. We can add another function here called heal. And we can loop through everything, but instead of destroying them, we will just call heal. That looks good. And then let's go back to our game manager. So here we can say mushroom field.heal now. It'll loop through everything. It'll heal them all. And I think we're good there. So let's test this out. Let's run this. I'm gonna speed up my centipede here to make this go a little bit quicker. And let me get hit by this. There we go. So I should have lost a life. If we go to our game manager, we can switch to the debug mode where we can see some of those private variables. So lives is now 2. That looks good. Let's test out that we get a game over. There we go. I got hit again. So now I have 1 life left. Yeah, lives is 1. Perfect. Let's get one more time here. Let's speed this up. Perfect. There we go. So the blaster completely disappeared now because it's got disabled. We can see that in our scene here. It's completely disabled. The centipede still moves, which is totally fine. But that was intentional. I wanted it to do that. And yeah, this is obviously we would display some game over UI and stuff, but we'll get to that. Oh yeah, and then I just clicked. So I just pressed an input and it restarted. I respawned, centipede respawned. I should have 3 lives again. Yeah, so the game started over again. That's all working correctly. I just noticed a problem as soon as I finished recording that last segment. So let's go ahead and fix something real quick. Let me show you what happens. If we destroy some of the mushrooms and then the round is reset, we're going to get an error. I didn't catch it the first time because I hadn't destroyed any of the mushrooms when I reset the round. So let's get one of these centipedes to hit me and we're going to get an error. Hit me, please. So yeah, so we get a null reference or a missing reference exception. The object of type sprite render has been destroyed, but you're still trying to access it. It's trying to access the sprite render on one of the mushrooms, but it's been destroyed because we killed the mushroom. You can actually see the full stack trace here. It happens when we try to heal everything, right? So we collide with a segment, it resets the round. That tells all of the mushrooms to heal. And then when we call the heal function on our mushroom, it's not able to access that sprite render because, well, it's been destroyed. That's a problem. And that's because in our mushroom script, we destroy some of these, but after destroying them, we never go and update our list here. We don't ever update our list. And so our list is keeping track of some destroyed objects, and then we're still trying to heal them. So that's no good. So to simplify this, what we can do, let's actually get rid of the list. We don't need it. There'll be an easier way to handle this. Get rid of the list. I'm just deleting. We don't need that import. We don't need the list. We don't need to initialize it. We don't need to add it here. We can just simply instantiate. This is kind of going back to how we originally had it. All we need to do instead now is get a reference to all the active mushrooms in the scene via find objects of type. So this is going to look in our scene for all the objects for all of our mushrooms. The ones that are destroyed, well, they're destroyed. They don't exist anymore. So it's not going to find those. And so now when we loop through everything, we're just looping through only the ones that actually exist. We don't need this line of code anymore. Same thing here. We can copy this same line of code here. We're going to find all the alive mushrooms in our scene. We'll loop through those and we'll heal those. Any ones that have been destroyed, we don't care about anymore. So that should fix our problem. Let's go ahead and test it out real quick. So let's destroy some of these mushrooms. Let's keep a couple of them at lower health as well, so we test that they are getting healed. I need to let the centipede actually hit me. So let's increase the speed here. And there we go. So, yep, no error. Those other ones got healed. Everything responds. So we're good now. We fixed that problem. Next, let's handle advancing to the next level whenever the player kills all of the segments in the centipede. Now, this is not a fully complete version of Centipede. So our next level here is going to be somewhat simple. But I can at least show you how to get this in place, and then I would challenge you to see how you can add more to the game to really make each level feel unique. So let's go to our centipedes, or just our centipede script here. And in the remove segment function, we should check after we've removed and destroyed that segment, are there any remaining in our list? If the count is 0, well, that means you've killed them all. And so we should call our next level function on our game manager. So we can say game manager.instance.next level here. And make sure this is public. That way you can access it from this other script. And so when we advance to the next level, really all I care to do for now, once again, this is a simplified version of the game, I'm going to increase the speed of the centipede. That way it gets progressively harder and harder as you continue to play. I can say centipede.speed maybe times equal maybe 1.1, which is 10%. So it's going to get 10% faster each time. You can obviously change that or do whatever you want. And then, of course, I need to respawn the centipede since you killed it. We could respawn the blaster, but I don't think we necessarily need to. We could also regenerate the mushroom field, but in the original game, they don't do that. The mushrooms kind of stay how they are. There are other objects in the scene, like there's a spider and other things that generate new mushrooms. And so just naturally over time, more and more mushrooms get spawned. So even if you start to destroy them, there's usually always mushrooms because of those other objects. Now, we're not going to go that far with our game for this tutorial, so maybe I should regenerate the mushroom field. But it's up to you. If you want to, you can essentially call some of these same functions, do whatever you want to. Obviously, in the original game as well, the whole color scheme of everything changes, but for our purposes here, this should suffice. So that's something, though, I really would challenge you to see. How can you implement some of those other features of the game? Let me just test this real quick. So I'm gonna increase the speed real quick. Oh no, I want to actually kill the snake so I can see that the speed changes. Let's set this back to the default of 20. Let's actually try to destroy it all. A couple more segments here. Let's get that one. Let's get that one. It's hard because if you miss, you sort of get penalized because then you have to wait for your bullet or your dart to respawn. Okay, there we go. So it respawned. Yeah, the speed is now 22, so it's 10% faster. And so as I continue to play, it's going to get harder and harder and harder. Mushrooms and everything stay exactly how they were, which is once again what I intended it to do. But feel free to customize that to your preference. All right, the only other thing we need to do is scoring. So let's go ahead and do that. Let's add, so we have our score variable in our game manager. We need to add some variables to our centipede and our mushroom to indicate how many points this is worth. So I'll only start with our mushroom here. We can add a variable for let's just say points. And I think mushrooms are only worth 1 point. Since there's a bunch of them, they're easy to destroy. For our centipede, I believe if it's a head, it's worth 50. So let's say points head, it's going to be 50 points or 100 points. I don't remember exactly what it is, but feel free to customize. It doesn't really matter. If it's a body piece, I think it's worth 10 points. And so we need to add a function to our game manager to increase the score. So let's add another public function here called increase score by some amount. And we'll update our score here. So score plus equals amount. And now we can call that function. So whenever you remove a segment, same thing here where maybe this is the very first thing we do. If the segment is the head, well then we will say, or I guess we're going to call that no matter what. So we can use a ternary. So we can say game manager instance increase score. And then if it's a head, we will increase by the points of the head, otherwise by the points of the body here. So once again, I'm using a ternary statement. It's going to evaluate this to true or false. If it's true, it uses this value. If it's false, it uses this value. And you can customize the points in the editor to your preference. You can also hard code them if you really want to. It doesn't really matter too much. So that looks good. Now, pretty much the same thing for our mushroom. Whenever you damage the mushroom or whenever the mushroom gets fully destroyed, we will call to our, I think it's when it gets destroyed. Maybe you could, it's up to you. If you want to give the player 1 point every time they damage it, you can just do it here instead, but I'm going to do it when it gets destroyed. We will increase the score by however many points the mushroom is worth, which I set it to 1, but you can customize this in the editor. So, oh, this looks good. Let's test that this works. Let's switch to debug mode so I can see my score since it's a private variable. And let's destroy a mushroom here. So yeah. Oh, I must have accidentally destroyed. Yeah, I destroyed a head. So I got 100 points. Destroyed a few things on accident. But yeah, obviously my score is changing. So getting points for killing mushrooms, for killing the centipedes, or yeah, the centipede segments. So everything is working there in terms of score. So this looks great. All right, at this point, all we have left to do is the UI for our game. Let's go ahead and throw that together real quick just to show you. I'm not going to make it super pretty, but I just want to show you how you can hook up UI for your game. Let's switch back to the normal mode here. Let's right click in our hierarchy and go to UI, and let's create a text component here. It's going to create a canvas. It's going to put that text as part of our canvas. It also creates an event system, which is used to handle like clicking buttons and things like that. So for our text here, you can see it showing up there. Let's start with our score text. Let's call it score. I'm going to anchor it to the top of the screen. So I'm going to go to this diagram here. I'm going to anchor to the top, and I'm going to set the Y position to 0. Although I need to change the pivot as well. Set the pivot to 1 and then set the Y to 0. And now it is going to show at the very top of our screen. Let's center align it. Change the color to white. Let's just initially set this to 0. And I'll make it a little bit bigger as well. That looks good. That'll be our score. Let's duplicate this and add one for lives now. This one I'm going to anchor to the right of the screen. And this one I also want to set the pivot on the X to 1 and then set this to 0. We want it to be right aligned. And I might want to offset this just a little bit from the edge of the screen. So maybe like -6 or so. Maybe this one's slightly smaller in size. No, we keep it doesn't matter. And we might also want to display a little like blaster icon so we understand what this value is for. So I can right click our canvas, go to UI image, and now I can assign the blaster to that. Obviously definitely want to make this smaller. So let's maybe say 16 by 16. We're going to anchor this to the top right corner, set the pivot to 1, and let's zero it out. Let's now adjust it a little bit. Maybe this is -20. Maybe a little bit more, 24. Bring it down a little bit. -6. That looks pretty good. I'm not trying to make this look super pretty. I'm just trying to show you how to do this. Let's go to UI. So we want to do our game over now, but there's going to be 2 separate text elements. So I'm going to first just create an empty object, sort of be the parent. So I'll call this game over. Now on that, I'm going to right click that. I'm going to create a text component. This one is center align. We're going to make it white. We're going to make it a lot bigger. Let's do, say, 32. Now, making it that much bigger, it now clips outside the bounds of our thing. So I could tell it to just overflow. And this one will be game over. So that looks fine. Let's duplicate this and offset the position below it. Say -40 or so. I'll make this one a little bit smaller. I'm going to say this one, press any key to play again. And yeah, that looks good. That looks fine. So we're good there. Now we just need to hook it up with our game manager. So let's edit this game manager. We need to add a few references to those different UI objects. So I guess first we need to import using Unity engine.ui. And now we can get a reference to, let's say, our score text, our lives text, and then to that parent game object for game over. Because we want to enable and disable that as a whole. So both of them together. So we'll just get a reference to the parent game object. We'll just maybe call this game over. And then in our code, when we start a new game, we should hide the game over. Game over set active to false. When we get a game over, we want to set it game over to be active, so that displays. And then anytime we change like score or lives, we need to update this text. So I find the best way to do this is to have a helper function for this. So we can say set score, and this can be, some value. And so we'll say score equals value, and then we'll update this text as well. And this will be score to string. Anytime the score changes, we're also going to update the text. And now basically the exact same thing for lives. I'll just change this to lives. Set lives. Lives equals value, lives text equals lives to string. And now anywhere we update the score or lives, we want to call these functions instead. So here we'll say set score to score plus amount. Here we'll say set lives to lives -1. And then here we'll say set score to 0, set lives to 3. This way, anytime you change these values, it's always going to update the text as well. So it's always up to date in the UI. That should be good. Let's test this out. We need to assign these different things here though. So let's assign score, let's assign lives, and let's assign game over. And let's test it out. So this should disappear right away because the new game starts. Good. As I play the game, my score increases. That all looks good. We're all good there. And let's go ahead and let one of the centipedes kill me so we can test that out. There we go. Our lives got updated to 2. So there we go. And let's test real quick that we get the game over whenever you fully die. There you go. So I have 1 life left. Let's get one more. Let's speed this up. Okay, and game over. Perfect. Blaster disappears. The centipede continues on, but 34 points, 0 lives, game over. I can click to play again and continue on. Everything resets. Great. So that's really it now for Centipede, at least as far as this tutorial. I definitely would encourage you to add more to the game. There's obviously more to Centipede than what we did here. There's spiders, there's some other, I think, scorpions. There's a number of other enemies that you can implement. So I would love to see what you can come up with, how you can extend upon this tutorial with new features, new functionality, new enemies, levels, etc. I really appreciate you watching this tutorial, and I hope you learned a thing or two along the way. Give the video a thumbs up or down to let me know how I did. Subscribe to the channel for more videos just like this one, and leave a comment recommending what you would like to see next. If you want to support my work even more, you can become a Patreon member to receive exclusive benefits, including access to the Unity assets that I develop. Link in the description of the video. Thank you for watching. See you in the next one.